At the bottom of that page, so this time they give you the description and you just have to sketch a graph that would have like an even degree and a leading coefficient that is positive. This negative word somehow got bumped from over here. And then number 5 is an odd degree and the leading coefficient of negative. So if it's even, you know both ends are going to go the same direction and leading coefficient positive. So you could draw something like a quadratic. If you want to do like a W shape, that's kind of like a quartic, 4th degree graph, something like that, where they're both pointing up. And then odd degree, so they're going to go in different directions, and the leading coefficient is negative, so like a linear function going down, a cubic function going down would be something that would fit that qualification. All right. So then the next page was just another idea that didn't really get touched on about polynomials, but it talks about turning points. So the true definition of a turning point is a point where the graph changes between increasing and decreasing. So I'm going to give you 2 examples. I'll post it. So for example, that does not have any turning points on it. This right here is considered a point of inflection, but this graph is just increasing, 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 increasing. So you have to have the graph going from, for example, increasing to decreasing at a turning point. Or it could look, something like this. So this one has 2 turning points on it. Both of these are cubic functions. This has 0 turning points, and this has 2 turning points. So functions that are the same degree can have different numbers of turning points, and the rule is if your degree is n, it can have at most n minus 1 turning point. So I just said these 2 functions here are 3rd degree. You could have at most 2 turning points. This is a parabola, 2nd degree. How many turning points does it have? It only has 1 turning point, 1 less than the degree. A linear function can have 0 turning points, right? It doesn't change direction. So linear 1st degree has 0 turning points. So I didn't need to give you this many questions, but what is the maximum number of turning points for each of the following? So it just requires you to identify like the leading term. So this one, for example, is in standard form, but not all of them are in standard form. So once you find the leading term, if this is 10th degree, it could have a maximum of 9 turning points. It probably won't have 9. It'll probably just have a couple turning points, but at most it could have 9 turning points. And we talked about yesterday the maximum number of zeros. This could have at max 10 zeros. So the number of x-intercepts is equal to the degree, and the number of turning points is 1 less than the degree. And you can kind of remember that from your quadratic. A quadratic has 1 turning point, but it could have 2 x-intercepts. A cubic function has 2 turning points, and it could have 1, 2, 3 x-intercepts. So this is asking you for the max turning points for each one. And then number 7, write an equation of a polynomial that would have maximum of 4 turning points. So if you could quickly do 1 through 7, and we'll check our answers in just a second. I'm just going to unpause my video here. So I just circled kind of what the leading term would be for each one if I rewrote it in standard form, and then just subtracted 1 from that power. Does that seem like what you got? And then this one was a linear function, so it can have 0 turning points. And then this could be any 5th degree function, but you could have kept going, like minus 2x squared plus 8x plus 1, whatever it is. As long as it's a 5th degree function, it would pass that qualification. So then number 8 and 9 are kind of like a putting it all together question that you might see on your test next week on polynomials. Probably just kind of a one-off question, not all these steps if it was on the quiz tomorrow. Like I might just say, hey, what's the degree of this function and what's its leading coefficient? So for example, if you were asked the degree for question number 8, this is already in factored form. So the degree is not 2. The degree is actually x squared times x, x to the fourth. So if it's in factored form, you got to be careful when you're talking about the degree. So this says use a graphing calculator to graph the function. I want to show you what you can do first without the graphing calculator. First, find the x and y intercepts. So we should know that the x-intercepts are at 0, +1, and -3, because it's the opposite of what's inside the factor, right? So 0 squared is 0, and that makes all of the 0. 1 minus 1 is 0. That makes the whole function equal to 0. So I'm going to plot 0, 1, and -3 on the x-axis, because those are x-intercepts. I don't really need to find my y-intercept because I know that it's at 0. But if I wanted to find the y-intercept, I would plug in 0 for all these x's. So 0 squared is 0, times -1 times 3 is 0. Because an x-intercept was 0, the y-intercept is 0. Determine whether each x-intercept is odd or even multiplicity, because remember that determines if it's going to cut through or bounce off the x-axis. So this is even multiplicity, right? But these two are both odd because they only have a power of 1. So we're going to bounce off at 0 and cut through at 1 and -3. I'm going to store that information for a second. Find the power function. That's another way of saying, can you find the overall degree of the function? So that we said was x to the fourth. Right? So we know this is a fourth degree, or sorry, I should say down here, but fourth degree. And determine the number of turning points. We're going to look at the calculator to figure out the exact number, but we can only have at most 3 turning points, right? Maximum. And determine the local min and max. The question I did not ask you here was the end behavior. So to sketch a graph without a calculator, I need to know what the right side of the graph is doing. Is it going up or down? The leading coefficient is +1, right? That's what's in front of all of this if I multiply out all my x's. So that tells me the right side of the graph would go up. We already said that we would cut through the axis at 1, bounce off the x-axis at 0, right? And then cut through the axis again at -3. So this is some shape of W looking graph. So now if you go onto a graphing calculator, if you have one near you, feel free to plug this in. If you want to just look up here for now, that's fine. Or grab one from the back or a different desk. So if I plug in the y equals menu, x squared times x minus 1 times x plus 3, I always hit zoom 6 because that's the 10 by 10 viewing window. So let's see how close we got. We got pretty accurate, right? We got a W-shaped graph. The only thing that was off was our 2 turning points, and you would really need a graphing calculator to figure out those turning points. So I just wanted to show you on a calculator, do you know how to figure out a turning point on a graph? So that's it's right above the trace button, calculate. So if some of you are doing this along with me, did you get the graph to show up? Okay, so we want to figure out what is that coordinate way down there. So you go to second, trace, which is calculate. Do you want to find an x-intercept, like a 0, a minimum, a maximum, an intersection point? We want to find a minimum because we want to find that coordinate right there. So I'm going to choose number 3. And then it's going to ask you a question. Are you on the left bound of your minimum? So no, my cursor is right there. So I'm going to use my arrow to get my cursor way over there. So now see how my cursor is to the left of that minimum value? Now I can hit enter. Now it's going to say, are you at the right side? So now you're going to move your cursor around to this side of that minimum. So see my cursor is now over here. I'm going to hit enter. It wants you to take a guess. So it really wants you to put the cursor like down here by the minimum. But if you just hit it a third time, it'll just do it anyway. So my minimum is at the coordinate -2, what? 0.2, comma, -12.4 about. So that is the coordinate of that turning point. So see if you can find the coordinate of this other turning point right here using the technology. So we found out everything else. We found out the x-intercepts, their multiplicity, the end behavior of the graph. The only thing we need to find out is the turning points on the calculator. So if I go to second, calculate again, minimum again, and then just move your cursor to the left and right of that minimum. So like left, and then I just hit it twice, right, yes. So mine came out, oh, let's see, 0.69 comma negative 0.54, something like that. If you haven't used the calculators in a while, sometimes it's hard to remember how to do all the steps. So just ask. All right, so I guess we're ending with here 9 today, because I don't know if we'll have time to do that page 10, but maybe we can brainstorm what would be on your quiz. So number 9, I can't start out yet because I'm not in factored form, and I'm also not in standard form, but the degree would be 3. I actually think it's easier to factor in this order because I can just pull out a greatest common factor of x. So if I pull out a greatest common factor of x, I would have 1 minus x squared left inside the parenthesis, right? Hopefully you know how to factor using a greatest common factor. And then hopefully you would recognize that this is the difference of squares, right? 1 and x squared are both perfect squares. So the way to factor difference of squares is a plus b and a minus b. So in this case, 1 minus x and 1 plus x. I just think it's easier to keep it in that order than deal with this negative sign in standard form. But so what are your 3 x-intercepts? So I should, now that I'm in factored form, I can tell what the 3 x-intercepts are, right? So, yep, -1, 1, and 0. They each have a multiplicity that's odd, right? Because they each show up once. So they're all odd multiplicities. So there's my -1, 1, or -1, 0, and 1. My 3 x-intercepts also happens to be my y-intercept again, because when I plug in 0, I get 0. An example for when you might need to find the like the y-intercept and it doesn't come out to be 0. Like if you had y equals x squared plus 2x plus 5, if you needed the y-intercept, you plug in 0 for that, you plug in 0 for that, the y-intercept is at 0, 5, right? So that's a different way of finding the y-intercept. You've actually found a number instead of everything just going away and getting 0. And then if we think about our end behavior, we would have a negative leading coefficient, right? Negative x cubed plus x would be standard form. So that tells me the right side of the graph is going to go where? Down, right? Right side's going down. And it's a cubic function, which is odd. So the left side of the graph has to go up, opposite. And then we know that it cuts through, cuts through, cuts through. So I just don't know those 2 turning points. So if you could take a minute and put that function into the calculator and determine those 2 turning points. And while you're trying that, I'm just going to put a list of kind of like the objectives for your quiz. Let's see. So if we graphed it, we'd have negative x to the third plus x, zoom 6. Seems very light. There we go. So if I go second calculate, minimum, I go to the left, I go to the right, hit enter twice. So let's see, this one was at negative 0.58 comma negative 0.38. Is that what people got for that one? And then the other one, second calculate maximum. If I go to the left and then I go to the right and hit enter twice, it was at, oh, basically just the opposite, right? So 0.58 comma 0.38. That sound like what you got? Okay. So